Okay, so this video is about finding the average rate of change of some function, um, or you can also think of that as the slope of the secant line. You might remember slope is often called rate of change, so of a function. So slope equals a rate, right? And it's a rate of change because the rate is it's a change in y in terms of a change in x, right? You might remember that. So when I say average rate of change of this function that's given here over the interval 0 to pi, I'm saying what's the rate of change from here to here? And that is asking the same question as what is the slope of this secant line right here? Right? A secant line is a line that cuts through a curve more than once there. Or it's not tangent to the curve, it actually like cuts through it. So let's write this. Average rate of change from x equals 0 to x equals pi. So this thing right here equals the slope of the secant line from x equals 0 to x equals pi. And that slope is going to be, well, let's look at our points here. This point here is 0, f of 0. This point is pi, f of pi. So the slope that we want is y2 minus y1 over x2 minus x1. And then if I just work that out a little bit, f of pi is 2 plus cosine of pi minus f of 0 is 2 plus cosine of 0 all over pi minus 0, which is just pi. And then cosine of pi is negative 1, so this turns into 1. Cosine of 0 is 0, so minus 2. Oh, sorry, cosine of pi is, yeah, that's right. Am I doing this right? Let me make sure. Oh, sorry, cosine of 0 is 1, so that's minus 2 plus 1 is minus 3 over pi. So we get negative 2 over pi. So that is the slope of this line right here. And it's also called average rate of change from 0 to pi, or on the interval 0 to pi. Okay, let's do one more example. So find the average rate of change of f of t equals t squared. So this graph right here is f of t equals t squared over the interval from 1 to 3 right here. So from here to here. So that means that graphically what we're asking for is the slope of, whoop, I missed it. The slope of, whoop, this line here that goes through those 2 points. This point down here is 1 f of 1. This point up here is 3 f of 3. And so we want the average rate of change from 1 to 3. So I'm going to write this out. Average rate of change from x, or t equals 1 to t equals 3. So that equals the slope of this secant line, which is f of 3 minus f of 1 over 3 minus 1. F of 3 is really just 3 squared, and f of 1 is 1 squared over 3 minus 1, which is 2. So that's going to be 8 over 2, which is 4. So that means that the slope of this line right here, slope equals 4. And so that's called the average rate of change. Now, there's this other question here. If f of t is a position function for some object, what's the average rate of change represent? So the idea here is that t would be in like seconds, let's say, and f or y would be in terms of like meters, right? So this would describe like how far you are from something. At 1 second, you're 1 meter away from something, and at 3 seconds, you're 9 meters away from something. If f of t represents some position, a position at time t, then that rate of change, that average rate of change from t equals 1 to t equals 3, that is represented by this same exact thing that we just calculated. But think of it this way. It's a change in meters over a change in time. A change in seconds, let's say, right, if we're looking at the units. So it's actually telling me over that certain time increment, over the 2 seconds, how many meters I've moved. So ultimately, the units for this thing are going to be in meters per second, and it tells me what my average velocity was from t equals 1 to t equals 3. Right? Now I don't actually know if it's meters per second, but it does give me a change in position over some change in time. And that always is considered a velocity. And in this case, it's the average velocity from t equals 1 to t equals 3. Okay? Yeah. So one other thing. In general, if we're looking for an average rate of change, then we've got some function, something like this, let's say. And let's say I'm looking from this point to this point. I want the average rate of change from A, f of A, to B, f of B. And the way that you calculate that is you find this secant line and you figure out its slope. Right? So the slope of the secant from, like, if we call this x and y, from x equals a to x equals b, that is considered the same thing as the average rate of change of the function from x equals a to x equals b, or on that interval, you can say. And that all equals f of b minus f of a all over b minus a. And it turns out if f equals a position function, then these all equal, then all this stuff here, then this represents your average velocity from time A to time B. So we'll say f of x represents a position function at time x, or your position at time x. Okay, then all that stuff from above represents your average velocity. Okay. I'm going to create a separate video for the next part. This is talking about average rate of change, which means slope of the secant line. The next part asks, well, how do you get an instant rate of change? So like in this picture up here, if I wanted like the rate of change just at that point, what I could do is draw a line through 2 points and then move this point so it gets closer and closer to that point. And what happens is that secant line, you know, if I first start like way over here, there's the first secant line. And then if I move the point a little bit closer, I get another secant line. I move the point a little bit closer, I get another secant line. If I get it so close, that secant turns into a tangent line right there. And then I would want the slope of that tangent line. So that's what we're going to do in the next video.